All right, gentle people, for this problem, what we need to do is identify concentrations of ions in solution. What this problem is testing you on is, do you know the dilution equation? M1V1 equals M2V2. Do you know that molarity equals moles over liters? And do you know that when you break up ionic compounds, that these ionic compounds break up stoichiometrically? So let's go ahead and take a look at our compounds in solution. So the first compound that we have is 0.25 molar of CoCl2. Now remember, this is an aqueous solution, and what that means is that CoCl2 does not really exist in solution. What happens is CoCl2 aqueous really means that I have cobalt ions that are aqueous plus Cl ions that are aqueous. But if we look at how this breaks up, there are 2 chloride ions per cobalt. So I'm going to generate 2 chloride ions when this breaks up and I dissolve the salt. So if the bottle is labeled 0.25 molar, that means I will generate 0.25 molar cobalt ions, but since chloride is in a 1:2 ratio, that means I'm going to generate twice as much chloride, so this becomes 0.5 molar. Now remember, all of this is in 50 mils. All right, let's go ahead and treat our nickel solution in the same way. The bottle is labeled 0.350 molar nickel chloride that's aqueous. So again, we're going to do the same thing. Our nickel chloride aqueous doesn't exist in solution. What does exist in solution are nickel ions and our chloride ions, but again, remember, 2 are generated per nickel chloride. So the same thing happens if this is labeled as 0.35 molar. That means the nickel is in a 1:1 ratio. So this is 0.350 molar, but this is twice as much, or 0.7 molar. And again, this is in a 25 ml solution. Now I'm going to combine these 2 solutions together, and my final solution will have a total volume of 75 mils. So now what we can do is we can start calculating concentrations of things. So when I combine these 2 solutions, you'll see that cobalt is only coming from one solution. And essentially what I'm doing is I'm diluting our solution of cobalt with another solution. So if I dilute something, I can use Mv equals Mv. So to figure out the cobalt ion concentration, I'm going to use M1V1 equals M2V2. So cobalt is only coming from our first solution, and it is at a molarity of 0.25 molar. The volume of the solution is 50 mils. I want to find the final volume of my cobalt ions in my final solution, which has a volume of 75 mils. I can go ahead and solve for M2, and when I solve for M2, I get 0.167 molar, and this is going to be the concentration of my cobalt 2 ions. I'm going to do the same for my nickel. So I have my nickel 2 ions, and I'm going to use M1V1 equals M2V2. I'm going to place all my concentrations in. So 0.350 molar in 25 mils equals M2, and the total volume of solution, 75 mils. I solve for M2, and I get 0.117 molar of my nickel 2 ion. All right, that takes care of these 2 metal ions, and you'll note that these 2 metal ions come from only one of the solutions. But chloride's a different story. Chloride comes from 2 different solutions, and I have to contend with this. So if you remember, molarity is moles over liter. So I should get the total moles of my chloride and divide by the total moles of solution. So what I want to get is the moles of chloride. To get moles, we're going to take the molarity times the volume. But remember, I'm after the total moles of chloride, and they are coming from two different locations, the cobalt solution and that nickel solution. So I'm going to put all these values in to get the total moles. So the molarity of cobalt in the first solution is 0.5 molar, and that's going to be the times the volume, and I'm going to change this into liters, so 0.05 liters, plus the molarity of my second solution, so 0.7 molar, times the volume in liters, so 0.025. And once I run this calculation out, I get that the total moles is 0.0425 moles of chloride. Now what I have to do is divide it by the total volume. So 75 milliliters is 0.075 liters. So our chloride concentration equals the moles over liters, and we just figured out the moles to be 0.0425 moles of chloride, and the volume is 0.075 liters. Doing this calculation out, I get 0.567 molar of chloride ion.